Black holes may lurk much closer to our Earth than we realize. The Milky Way should be teeming with small black holes, somewhere out there lurking in the corners of our galaxy. An estimated 10 million to 1 billion stellar mass black holes are thought to be just hanging around, dark and mysterious. Because we can't usually see them, unless they're active, we can't take a census, nor do we know where in the Milky Way they are. We only know if around 20 stellar mass black holes in our galaxy. We know of 20 stellar mass black holes, with the closest candidate to Earth sitting around 1,565 light years away from us, but a new study suggests that they could be a lot closer than we think, right in fact in our cosmic doorstep. By analyzing and modeling the Hyades cluster, a group of stars located 150 light years away, a team of astronomers has found that there could be 2 or 3 stellar mass black holes hidden in there. Our simulations can only simultaneously match the mass and size of the Hyades if some black holes are present at the center of the cluster today, or until recently, says astrophysicist Stefano Torniamenti of University of Padua in Italy. In Hyades, visible to the naked eye in the night sky of the constellation of Taurus, is what is known as an open cluster, a group of stars that share the same characteristics, moving together through space in a gravitationally bound blob. Each open cluster is basically a family of sibling stars, all born from the same huge molecular cloud, hanging out together before eventually going their separate ways. The Hyades is thought to be around 625 million years old and contains hundreds of stars, with those at the greatest distance from the center apparently starting to break away, and those at the center grouped the most densely. In these densely packed environments, stars are expected to jostle each other at a higher rate than we'd see in less populated stellar environments, resulting in a higher rate of collisions and mergers. And here in the heart of star clusters, astronomers predict that black holes can be found, the ultimate product of these interactions. We've seen hints of them in other kinds of clusters, but because black holes don't give off any light unless they're actively munching on star flesh, finding them is a challenge. Torniamenti and his colleagues conducted their search of the Hyades in a more indirect fashion. They modeled the mass and stellar motions of the cluster using data from Gaia, a satellite mapping the three-dimensional positions and velocities of the stars in the Milky Way. And then they performed simulations to try to reproduce those observations. They found that their simulations were the closest match to the observed cluster when they included 2 or 3 stellar mass black holes in the mix. These black holes are either still present in the cluster or were ejected less than 150 million years ago, which means they would now be hovering around its outskirts. This recent ejection would mean that the science of the black hole's gravitational effects would still linger in the cluster core. And of the black holes themselves, the researchers were not able to identify precise locations, but the finding, they say, is strongly indicative of the Hyades containing the closest candidate black holes in the solar system, more than 10 times closer than the previous candidate. Were not to be clear in any danger from them, the researchers found that the fastest any of these black holes could be moving was 3 kilometers per second, and even if they travel in our direction, it would take them a very, very long time to get here. And anyway, black holes have no greater gravitational pull than any star of equivalent mass, so we're in no more danger from rogue stellar mass black holes than rogue stars of the same mass. We wouldn't see it coming, but what are we going to do in either case? We can't do anything about it. Rather, the discovery helps us better understand the invisible population of stellar mass black holes in the Milky Way. This observation helps us to understand how the presence of black holes affects the evolution of star clusters and how star clusters in turn contribute to gravitational wave sources, says astrophysicist Marc Giels of the University of Barcelona. The results also give us insight into how these mysterious objects are distributed across the galaxy. Their research has been published in monthly notices of the Royal Astronomical Society, and this is by Michelle Starr and Science Alert. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.